everyone, and welcome to another episode of Pathfinder, a podcast by Payload, the leading digital media company in the space industry. I'm your host, Mo Islam, and today we're joined by Hélène Huby, the co-founder and CEO of the Exploration Company, a Berlin-based company building cargo and crew capsules. The company is building the first privately funded European crew capsule. We talk about the market for capsule technology, challenges, and a vision for global space exploration. But before we jump in, a brief word from our sponsors. SpiderOak's Orbit Secure software is designed for hybrid space operators struggling to manage the chaos of securing data flow and access to and from tens of thousands of small satellites in low Earth orbit. Using a unique combination of end-to-end zero-trust encryption and blockchain distributed ledger, Orbit Secure allows your mission to orchestrate and secure Earth-to-orbit, orbit-to-Earth transmission, communication, and storage of sensitive data across even the most complex and unsecure hybrid space environments. To learn how Orbit Secure can bring zero-trust security and resiliency to your zero-gravity environments, check out SpiderOak at www.spideroak.com. Hélène, welcome to the show.
Thank you very much, Mo.
Excited to have you. Where are you calling in from?
Actually, I'm in India today, in Bangalore.
India! I was
Yes.
I was not expecting you to say that. What are you doing in India?
So we are a European-based company. We're also, of course, working with international partners, and we are currently cooperating with India. So I'm here to push our cooperation to the next level, basically.
Wow. So it's actually pretty late over there. I appreciate you joining. You're burning the midnight oil, that's for sure. Well, so why don't we start and tell us a little bit about what you do, and would love to hear about how you've come to start the Exploration Company. So maybe give us a little bit of background about yourself and your career so far.
Yeah. So I've been working in the aerospace industry for around about 10 years before I started 2 years ago the Exploration Company, mainly in the big corporates in Europe, so ArianeGroup, Airbus. On the one hand, corporate functions, I was head of innovation for Airbus Defence and Space. I was the VP for space strategy for the Airbus Group. And most importantly, in my A's, in operational functions. So I led a small launcher program at ArianeGroup, and I was the VP for the European Service Module, so second biggest space program in Europe. And it's basically the European contribution to the Orion vehicle that flew around the moon, came back, and is going to bring back, to the moon the next generation of American astronauts and also some European astronauts. So while we were working on Orion, actually, it's amazing because you bring back humanity to the moon, but Orion is also a vehicle which is kind of traditional, I would say, because cannot be reused, cannot be refueled. And if you look in the main technical trends, it was for me very clear that any new kind of vehicle that will be built in the future, also for in-space transportation, so like capsules, spaceships, the standard will be in the next 10 to 15 years vehicles that can be reused and can be refueled. Plus, in Europe, apart from like 50% of Orion, we have no capacity to explore the new space worlds. We have no capacity to contribute, to participate to this human expansion. So basically, I said, okay, let's build this European capacity and let's do it at the top of the technology. That is to say, let's build capsules, spaceships that can be reused and can be refueled. And since now 2 years and 2 months, this is what we're doing. So we start with a LEO vehicle that can carry cargo with the potential to fly humans, because that's step number one. And basically, we reuse the same techno bricks to afterwards fly to Gateway and lunar surface and come back. So a bit like Soyuz capsule was designed to be able to come back from the moon. We design our capsules that it can also sustain a lunar re-entry, but we start with low Earth orbit and we start with cargo because that's the kind of easiest step before you go to, let's say, far destinations.
Let's take a quick step back and just talk about the European market for a second. So as far as crew capsule goes, obviously there's the Crew Dragon. Everyone knows that one.
Yes.
People are very aware of Starliner, but probably for the wrong reasons. But so there's Crew Dragon, there's Starliner. But in Europe, if we're talking about European capabilities of capsules currently operational today, what is there?
Nothing.
There you go. So
that's why we're here. Actually, exactly why we're here.
So can you give us a little bit of sense of why that's the case? Why is there no government-funded capsule right now?
Yeah, and what's also super interesting, if I may, is that, as you say, there is no government-funded capsule. And what we did was actually pretty bold. because, if you look at how Dragon was funded, it was funded by NASA.
Mm-hmm. Mm-hmm.
And
that's right.
The Starliner is also funded by NASA, right? And the Chinese capsule is funded by the Chinese Space Agency, and Soyuz was funded by Roskosmos. So what we did is Europe needs its own capsule. And I think we also need more competition, generally speaking, in this in-space transportation. So we just created a company and raised private money, because we said, let's not wait until, Italy and France and Germany, they're going to come together and to say, hey, we need to build a capsule, because this can take years. So we are now funding this capsule privately. And now Europe is coming as a client. And normally next week shall be ready to say, hey, we open a competition to do first COTS contract and act as an anchor client of basically the Exploration company and potentially some other players in Europe. But you're right, Europe has no capacity. There are, let's say, two main reasons for that. The first is that Europe had the willingness in the past to build a spaceship that was called Hermes, and actually Ariane 5 was designed to fly Hermes. So at the beginning, when Ariane 5 was developed, it was a launcher that should have been human-rated. And then the cost of Hermes went up and up and up and up. And Ariane 5 also had some problems. You may recall that the first launch of Ariane 5 was actually a failure. So then the whole European money was put on Ariane 5, and we basically abandoned this idea of flying humans. And then what Europe did was to actually develop the ATVs, the Automated Transfer Vehicle, that was docking with the Russian part of the station. So that project was actually quite successful, and there were several missions. They were all successful, including the first one. But that vehicle was still costing a lot of money, because it was around about 500 million per mission. And then Europe decided, there was the choice either to continue the ATV, so Automated Transfer Vehicle, and kind of to change it. There were plans to have a version that could come back and that could pave the way to a kind of man-rated ATV. But there was also the opportunity for Europe to participate to the Orion as a barter, let's say, agreement with NASA. And at the end, the decision was taken that Europe should better do the European Service Module and not the ATV. So these two programs were stopped. Hermes was stopped because cost increase. ATV was not pursued, also because kind of very expensive vehicle. And that's the reason. And I think, so one reason, of course, is cost. But I have to say also another reason is sometimes we lack the right ambition. And while, we've been very ambitious in saying, hey, we want to create a euro. This was a crazy idea to say we have just one money for all these countries. Or to say, hey, we want to create Airbus at the time when Boeing was so strong. And now we are really, like the main competitor of Boeing. So sometimes we have the ambition, but for whatever reason, I think we lacked the ambition on this human space side. But it is now coming again with private players like us. And also on the side of the member states, and the general director of the European Space Agency is right now pushing very hard so that Europe takes the decision to come back and participate to this human spaceflight race that we're seeing in space. So we hope it's going to come back. But we don't want to wait. So we just did it, founded the company. In 2 years, raised around about 70 million USD. And we've won around about 175 million USD contract. So it's, for the time being, in 2 years and 2 months, it's quite good.
All right. Well, we're going to talk a little bit about your commercial traction in a bit. I do have a bit of a question more about you. So, if you took a bunch of names of space entrepreneurs and space startups, and you put them in a hat, and you pulled a name out of a hat, generally, I think the probability would be that they're either a launch startup CEO or the CEO of some remote sensing satellite company, right? I have not heard of someone who wants to build crew capsules, right? And that's not those are not entrepreneurs that you come across often. So I'm curious, why was this a problem that you felt so interested in solving? And what made you feel like you were the right person and you've built this team? Why do you feel like this is the right team to solve this challenge? Because it is very non-trivial. Like when you're building a launch company, there's so much data out there on launch and different types of propulsion technologies and different types of systems and architectures that you can pursue. There's not that that does not exist nearly to the scale that it exists for something like launch or even satellite manufacturing. So the technological challenge seems just completely different. So maybe talk a little bit about that.
Yeah, you are right. It's quite bold when you look back, and if you zoom out, you only have 3 countries in the world actually which are mastering the capsule technology. It's US, China, and Russia, and you have now around about 8 countries in the world which are mastering the launch technology. So you could say, okay, it's kind of like twice more difficult than a launcher, but I think anyhow. So the reason was quite simple. When we thought about what kind of things we want to create, let's say when I was at Airbus, was for me very clear that either I stay at Airbus and I use all my energy to transform Airbus, or I get out of Airbus and I build a company that will be transformational. I am driven by transforming in a positive manner, so by creating positive impact around me, thanks to the competencies and whatever skills I can have. And so when we started to think about the expression company, I basically put 3 criteria that we had to meet. Number 1 is it has to be transformational for Europe and for the world. So whatever we do, it's not going to be small. It has to be transformational and, of course, a positive impact. Second, it shall be a 1 billion company in 5 years. Because if you really want to transform, you have to be very successful business-wise. Otherwise, you have no future and your impact is very limited. And third, we have to do something which is absolutely linked and, let's say, unleashing our core competencies. And I had been working on Orion for, let's say, 3 years. I was seeing this market of exploration growing because you have more and more destinations. You will have more stations around the Earth. You have new stations around the Moon. And I believe there will be also new type of station around the Earth, not only civil stations, but also military station and refueling station, etc. So all these new infrastructures will have logistic needs in terms of goods, so cargo, people, and defense, cargo or whatsoever, or also propellant. And if you look at now the vehicles that can serve these needs, you end up with what you were saying at the beginning. Very few vehicles in the world. And most of them cannot be reused, and most of them do not come back. So apart from SpaceX, basically, you do not have vehicles that are affordable, are reliable, and are reusable. So we saw an opportunity to do something that would be, that would be number 1 in Europe, that would be the challenger of SpaceX worldwide on this capsule segment. And yes, it's very hard, this is clear, but this was related to actually our core competencies. So I think I wouldn't have launched such a business if I wouldn't have been working for several years on the Orion program, for sure.
Right. No, it makes sense. Okay, let's talk about the product. I hope I don't pronounce it incorrectly, but Nix is the first capsule.
Yeah.
Yeah. So tell us a little bit about Nix. What is the? Give us a little sense of what it is, what it looks like, some of the kind of overall tech specs.
Yeah. So it's a capsule round about the size of Dragon. So it's a 4-meter diameter. It's a bit more than 10 ton. So we'll be landing around about 11 ton roundabout. Dragon is 12 ton, just to give an order of magnitude. In terms of up and down mass, we can bring 4 to 6 ton up. In terms of down mass, we can bring down to Earth around about 2.6 ton. And it's reusable, of course. So you have 2 bricks, the capsule brick, with propulsion system inside that comes back, can be reused. And then you have a second brick, which is the service module, which is filled with cargo when we go to station. And when we re-enter, we destroy basically the garbage in the atmosphere. So that service module actually is destroyed in the atmosphere. But the vehicle is modular. So we are reusing the same architecture when we fly to Gateway, for example. It's the same capsule, it's the same service module. The only thing we add inside the service module, a second propulsion system, because we need more energy to go to Gateway. So we add here a cryogenic propulsion system. And I think what is very nice is that the second propulsion system will have the potential to be refueled. So then we'll be able to fly around Gateway, we'll be able to land at lunar surface being refueled, and then basically reuse that vehicle in space several times thanks to the refueling. What is very specific and what is for Nix On the one hand, this refueling capacity that I was talking about, and on the other hand, and this will come very fast actually, because this will be part of our first product. We are flying with green propulsion system. So we are using hydrogen peroxide with a fuel, a hypergolic fuel. And it means this is way less toxic than hydrazine, which is used by all the exploration vehicle right now. Orion is using a derivative of hydrazine. Dragon is using hydrazine. Soyuz using hydrazine. They're all using hydrazine, which is hypertoxic. So we are kind of pioneering a green technology, which was there in the space industry since decades, but was never industrialized because it has some technical challenges, of course. But we are really pioneering something here. And this shall, on the one hand, of course, it's better for the environment. On the other hand, it's also, it costs less because it's less toxic. So in terms of the way you operate the capsule, you don't have to put a scaphandler when you fuel it. When it comes back, it's splashdown. You don't have to have sniffers, etc. So less cost. And on top of that, probably more reusability capacity because less toxicity. So that's what we're a little bit excited about. And then on the roadmap, just
so Helene, just to ask the obvious question. I was going to just say that, just ask the obvious question. It sounds like there's so many substantial benefits from not using hydrazine and going the route that you are. Why is it the case that
everybody's using hydrazine?
The other, yeah, exactly.
Because actually hydrazine has great advantages. The main one is this is something which is known, and when you want to develop a new vehicle, you don't want to go too much in the unknown because you have enough problem with simply the development of the vehicle. So it's an additional risk that we take, to be very clear. And the problem with green propulsion is that it decomposes. So if you stay really, really very long in orbit, and if you are not if you don't use these propellants at a very, very high density or level of purity, then it will decompose faster. But that being said, it decomposes in months or in years. So if it's just to do a cargo mission where you need the vehicle to be operational for up to 6 months, basically, it's absolutely fine. But it has this problem. It has some material compatibility problem, and also the ignition has for years not been properly mastered. So the ignition was happening with a catalytic bed. This was technology normally used for green propulsion, and this is not very reliable. So if you go to station, you need a system which is super, super reliable. Because the only thing you have to do at the end of the day, if something goes wrong, if you fly with crew, you need to be able to bring that crew back. And if you just fly cargo, whatever happens, you need to be able to perform an avoidance maneuver, not to collide with the station. So you need to be able to avoid the station, whatever happens. And for that, you need a very, very reliable propulsion system. So that's why hydrazine has been used for years. And that's why also if we wanted to go kind of the safe road, we would have said, okay, let's use hydrazine. But we've seen green developing more and more. We see the technology maturing. So we're kind of leveraging this maturation of technology to say, okay, probably, in the next 10 to 15 years, that will be a standard. So let's anticipate that and let's take the risk actually to industrialize that technology.
Sure. Now, outside of the propulsion architecture, how would you compare Nix versus Starliner and Crew Dragon? And by the way, I'm not trying to say it needs to be different because quite frankly, based on what you're saying alone, that the fact that Europe does not have its own capsule system, it could be the same outside of certain things. But I'm just curious, is there any other stark differences from the way you're building versus the other two?
A big difference, and this relates also to the mission of the company, is that we are launcher agnostic. So we can fly, India today, for example, because we want to be able to fly with GSLV, which is the heavy launcher of India, right? We want to be able to fly with H3, which is the heavy launcher of Japan. Of course, we'll be able to fly with Ariane, and we have shortlisted 3 launchers in the US with which we want to be able to fly. So we are launcher agnostic. And this is for us important in terms of, let's say, value, because we want to create spaceships or vehicles which, as much as possible, contribute to build a cooperative space world, right? Space is an area for wars, for confrontation, for race, but it has been, and I really wish will be also for years, an inspiration for peace and for cooperation. So we want to be able to launch with as many launchers in the world as possible, and we want to be able to dock with as many stations as possible. So technically, we want to be able also to serve the Chinese space station. It's very difficult to do that, almost impossible to do that right now, but that's something we want to bring. So for, let's say, for the mission of the company, we have this agnosticity of launchers. That also has a great advantage in terms of costs, because you can play the competition, and launch cost is quite important in the cost base. And that has also a business advantage, because who are our clients? Our clients are private space station on the one hand, and space agency on the other hand. So, like, if we want the Japanese space agency to buy a mission to the exploration company, and if we can say to the Japanese space agency, you know what, we use a Japanese launcher, of course we have more chances to win this contract. Same with India, and same with Europe, and same for the US market. So these are the two specificities of our vehicle: green on the one hand, and this launcher agnosticity. For the rest, we are quite similar.
So you're initially focused on cargo, the first iteration of the vehicle, and then eventually for human transport. How are you designing the vehicle from ground up with an eye towards human transport? What are sort of some of the design challenges or considerations that you have to take into consideration when you're doing that?
So there are, let's say, there are two questions in your question. One is kind of the roadmap and what are the main risks. And the second is, how do we manage this? We start with cargo, but we want to go to crew. So to answer the second part, like we start with cargo, but want to go to crew, that's quite simple, actually. When we go to station, we have to respect the 50808 requirements, which is a requirement documentation that has been published by NASA. And you have some cargo requirement and you have some crew requirement. So all the crew requirement we can respect from day one without having a big impact on the planning and or on the costs. Then we integrate them so that we are as much as possible prepared for the crew. There are things we don't do, like we will not have an abort system, because what's the point to have an abort system when you have cargo on board? It's stupid. What's the point to have toilets when you don't have cargo on board? It's stupid. But we know that we'll need to have this kind of different life support systems. So in the design, we plan for the size already. And all, let's say, the crew requirements that we can implement, which do not have, as I was saying, a big impact on the costs or planning, then we take them on board already for the cargo version. Then in terms of, let's say, roadmap in general, and this applies to crew as well as cargo, at the end of the day, we have three main risks we need to de-risk. The first risk is the re-entry. And for re-entry, you shall not burn, you shall not land in New York, this would be horrible, and you shall not also explode when you splash down. You need to have the parachute opening properly, and okay. So on these three, to de-risk the whole re-entry, we are producing right now actually 2 capsules, very small one which is ready for flight, and will fly with an Indian launcher in Q1 24. And a second one, which is currently being integrated. The integration will be finished in Q1 24 and will launch with SpaceX end of 24. So with these 2 demonstrators, basically, we fully de-risk the re-entry risk. We'll know how to guide, we'll know how to, let's say, brake, so the parachute, etc., and we'll know how to make sure that we don't burn. So that's risk number 1 that will be behind us normally beginning of 25 and 24. The risk number 2 is the docking. Because we shall not collide with the station, we shall dock properly, and we'll go directly for docking. That's also a way, with cargo, you can like burst at the beginning, and then you may be willing to dock. We decided to go directly for docking, and here we'll de-risk on ground first, and then we fly. That's how the ATV has done. That's also how it has been done, with Dragon, etc. So de-risking on ground and then flying. And the third risk is this green propulsion system, which we're adding because we're using. So here, same, we de-risk on ground and then we fly. So first flight in 27 with the full product, and before that, 2 demo flights in 24.
Wow, that's next year.
Yeah, this is next year.
Did I hear that correctly? You said 2024. Okay, so you have a demo.
Next year is going to be very, very important for us.
Oh, okay, amazing. So now I do have a question that I know you have an answer to, but Ariane 6, I think you were supposed to launch on Ariane 6.
Exactly,
and
yes.
There's been delays. How much of your schedule is dependent upon Ariane, of your demo schedule, dependent upon when Ariane 6 flies?
Yeah, that's a great question. Actually, today, 0.
Okay.
For the first capsule, actually we won an award to be launched by Ariane 6 almost for free in December 22. So we built our first capsule in 9 months for around about 1 million. It's a very simple capsule, it's small one, etc. But still, it's still a spacecraft, and so we kind of did this baby capsule like a baby in 9 months. But then, Ariane 6 was late. So long story short, we changed launchers. This happened last year, and decided to choose an Indian launcher because it's also enabled us to develop some very interesting partnership with India, which is a great space nation. So we signed with NSIL in summer 22, and so we launch in summer 23, and we launch in Q1 24. So then for the first baby capsule, we're not dependent anymore, and for the second capsule, we were launched by SpaceX. And which again, I appreciate that despite the fact that we will be, if everything goes well, competitor in the capsule business, they still want to serve us on the launcher business, which are doing also with other satellites companies, willing, for example, to like OneWeb. They are selling also OneWeb. So it's and so here it's for end of 24 and perhaps beginning of 25, but that's the schedule we have in mind right now.
I see. So first demo mission on via India, second mission via SpaceX.
Exactly.
And the second capsule is going to be it's going to be an upgraded version of the first demo?
Yeah, the second capsule is the first one is very small. It's 40 kilogram, 60 centimeter.
Okay.
The second one is 10 times bigger. So it's 1.6 ton. It's 2.5 meter diameter. So it starts really to be a capsule. We have cargo client on board. So we're flying with payload from the European Space Agency, German Space Agency, French Space Agency. Also Airbus is a client and flies with us a payload. So that's and here that's a full mission. So we guide the re-entry with thrusters. It will use, of course, for the GNC that we've developed in-house, the flight software that we've developed in-house. We open the parachutes and we splash down and we recover the capsule. So that second capsule is very, very important. And then we go for full size, which is, a bit more than 10 ton. We'll probably land around about 11. And so a bit more than 8 meter high and a little bit more than 4 meter diameter.
And then when did you say the full size?
The final one, full size. Yeah, so we plan to go to station in 27.
27. Okay. Amazing. Well, super exciting, very interesting. But Helene, we're going to need to take a very quick break. And then when we get back, we're going to talk a little bit about the business model and the market, because that certainly is what I'm sure a lot of your investors have asked. So we'll be right back. So just stay with us. Space is the new frontier for cybersecurity. To quote the commander of the U.S. Space Force's Operations Command, cyber threats are unfortunately the soft underbelly of our global space networks. SpiderOak, the leader in space cybersecurity software, is dedicated to providing space operators with the solutions they need to protect hybrid space systems. Their Orbit Secure software uses a unique combination of end-to-end zero-trust encryption and blockchain distributed ledger, allowing missions to orchestrate and secure Earth-to-orbit, orbit-to-Earth transmission, communication, and storage of sensitive data across even the most complex and unsecure LEO and hybrid space systems. To learn how Orbit Secure can bring zero-trust security and resiliency to your zero-gravity environments, check out SpiderOak at www.spideroak.com. Okay, so I want to talk now about the business model. So, how does a company generate revenue? And maybe talk a little bit about that model. You mentioned earlier that most of your customers are going to be space agencies for the most part, and countries and governments, right, for the most part. Maybe talk about what that customer base also looks like. Let's start there.
Yeah. So actually, our business model is very simple. We sell missions. So like DHL or like, CMS, CGM. So like any logistic company, we do logistic. So we sell logistic service. So if you're a client, and typical clients are on the one hand, private space stations. like Axiom Space, Voyager, VAST. Other type of clients are space agencies. These are basically our two main clients. You buy a mission, and we price a mission around about 150 million USD. So kind of simple. So you buy a mission. When we signed a deal, for example, with Axiom Space, we signed a deal, some weeks ago. They are buying, provided we have some milestones to meet in 25, but provided we meet some milestone in 25, then they are buying a full mission that will fly to Axiom Space not sooner than end of 27. And so what's going to happen is that Axiom will give us, their cargo payload, and we'll take care of that. We take care of the launcher. So in that price, you have, of course, the launcher price in it. And that's where it's very important for us to be able to play the competition between the launcher so that we can really select, the best launcher from a quality and price perspective. And then we fly. So we operate the vehicle. And we bring up whatever the client wanted to be brought up, and then we bring down whatever the client wanted to be brought down. And we give the payload back to the client when it's brought down. So it's a service model. And of course, it's a bit like SpaceX, selling services and having, of course, like hands-on the development of the launcher and all the industrial capability.
So let's talk about space stations for a second. So right now we have the ISS going to be decommissioned by the end of the decade, maybe a little past the end of the decade. The ISS is getting to be decommissioned. China has Tiangong, right? So they have their version of their space station. Russia has its own plans, timeline unknown. But for the most part, at least for the Western world, there's no government-backed station business anymore, right?
Exactly.
And now you obviously have commercial players, private players like Axiom, you mentioned, like Sierra and Blue Origin, like Voyager. Do you feel like the success of your business is dependent upon their success, or do you see a market that's even beyond that? Because there's also a question of like, well, investors ask the question, well, yes, amazing. I understand space station research exploration, but is there a business model behind the space station? Now, I believe that there is, right? So there's no need to convince me, but I'm curious how you think about, how much the space station infrastructure is important for your business.
Yeah, that's a great question, actually. So what we're seeing actually in the world and what you described is that we are moving from a world of, let's say, 2 space stations, the Chinese one and the ISS, to a world of more space station. And why do we have more space station? One reason is you have more and more countries which wants to do stuff in orbit. So like, okay, Russia wants to have its own because it's departing from the ISS. Like Saudi also is thinking about having a space station. For example, like India recently announced they're going to have a space station. So like more and more countries wants to do stuff. It can be renting some square meters in a private space station, or it can be investing to build their own space station. But there will be more activities just, pushed by, I would say, government. The second reason is that we have this race to the moon. And so that's also government back. This is clear. So there'll be 2 new destinations around the moon. And there is also a need to do more experiments around the Earth to prepare us really living at lunar surface and having a sustainable ecosystem at lunar surface, because it's easier to do experiments, around the Earth than to go directly to moon. So there is this second drive for more experiment in station around the Earth is, let's say, the lunar race. And a third driver, which also is popping up, which is, I think, very important, is you take Starship, one Starship, I'm caricaturing, $1 million USD, one station. So it becomes much more affordable and much easier to launch station into space. And you also see that space infrastructure are becoming more and more critical. If someone like destroys GPS or whatsoever, like there'll be huge damages on Earth, of course, and like all the drones in the US, can they fly or not without GPS, etc. So, and then if tomorrow in 10, 15 years, I don't know, like 50% of the communication actually is space-based, And there is, again, so hacking or whatsoever. So it means the space infrastructure have become absolutely critical. So there is a need for action in space, protection in space on the space infrastructure. So I believe there will be not only civil space station, but also military space station that will be storing vessels and or satellites to improve the resilience of the constellation, as well as tank station to refuel these vessels, so that there is a fast in-space action capability. And this will come, I think, in the next 10 years also. And it will be increased and accelerated by this very big launcher like Starship that make basically the building of space station much more easier. So without even talking about the private business, just what I've just described right now, which is more and more states willing to do stuff in space, plus race to the moon, plus militarization of in-space logistics, this is just calling for a growth of the business, while number of vehicles stays roundabout stable. On top of that, you have indeed potential for private business, which is manufacturing in space for the Earth, research in space for the Earth, also storing computers for in-space calculation or for like protecting data, for having data centers in space, for example. So all of this private business today, I think there's a big unknown. So when I speak to my investors, I present what I think is sure, or like without any doubt, because we need to build a business on something which is, somehow like basics. But this private business is a huge multiplier that potentially could take off in the next 5, 10, 15 years. The point is now there is a lot of unknown, because the killer application, will it be pharma, will it be agro, will it be like storage of computer, has not been found yet. But I think everybody feels that there is a huge potential. And I think this is a bit like when in the 16th century, 15th century, like we started to discover the Earth, people were saying, hey, we're going to find, spices, or we're going to find gold, or we're going to find... We find that we found other stuff, and like new businesses also popped up. So I think it's a bit here. We don't know what we're going to find, but for sure, when you have an infrastructure, which are station plus transportation system, which has become affordable, reliable, then businesses will pop up.
Yeah, no, I buy that. I definitely buy that. I mean, the ISS alone cost $100 billion, and most of the companies we're talking about are fractions of that cost. And when you're talking about such a significant drop in cost, you actually start to see a real business model form around activity that never was considered to be, commercial and economic. So with that, I do have a question about cost. So, you look at Mercury, Gemini, the Apollo command module, somewhere between $3 billion to $30 billion to build. Crew Dragon cost around $1.7 billion, maybe closer to $2 billion if you inflation adjust. Those are big numbers. And I think you said so far you've raised about 70 million USD. And if I'm not mistaken, you're already on the pad next year, and potentially twice to go to space. So talk about how do you bridge the gap of like billions of dollars needed on R&D to build the capsule, and how do you do it in a way using private investors that is achievable? And will you need some type of European government agency or European entity to say, hey, Helene, here's $1 billion, go and continue building this thing?
Yeah, that's a great question. I think we need to differentiate between cargo and crew. If you develop a crew vehicle, it's typically 10 years, and it's honestly very difficult to do it for less than 1 billion. And then the risk reward for a private investor is a little bit hard, honestly, because who as a private investor would say, hey, I want to invest 1 billion, or let's say 1.5 or whatever, like 2 billion. And I'm happy to wait 10 years and then we'll see. not a lot of private investors. Cargo is different, because cargo, basically you can have a reliable cargo capsule for around about 300, 400 million. And it took 6.5 years to SpaceX from the first award of the COTS contract in 2006 to the docking of Cargo Dragon. So 6.5 years, 300, 400 million. This is something an investor can think about, and the risk associated also much lower. So that's also why we start with cargo. And this is what we want to fund privately. And what we have in mind is, if you take 400 million just as a rough estimation, is to fund around about 250 through private investment. So like the majority of the development cost, and then to have a first contract coming from, well, Axiom have already signed the deal, could also come from the European Space Agency. And I encourage you to look at what's going to happen the 6th of November, so next Monday, because there'll be Space Council in Europe. And if everything goes well, but it's politics, so it can blow up until the last minute. But if everything goes well, we should have a very nice announcement from Europe, potentially opening a competition to give the first mission to one or two players, potentially 3 players in Europe to fly a cargo capsule. So what we have in mind as a businessman is, okay, there will be around about 150 paid by European Space Agency or a client. And this is a client, so they pay the price of a mission, and we'll take care of the rest through private investors that will fund basically development. And we believe this is feasible, especially because, Europe has its own cargo need. Europe has also a need to barter with private space station, because the barter will not be with NASA anymore. The way we fly our astronauts today is that we have a barter between European Space Agency and NASA. And when there is a European astronaut being flown on SpaceX, well, actually, this is NASA paying for that. And in exchange, Europe gives to NASA stuff like the European Service Module. So there is this barter. And this barter will be reinvented, I guess, in the post-ISS era, because Europe or India or, whatever kind of country, they do not want to give all the cash they have to develop so they want to develop their own industry and exchange something useful for the private space station in exchange of services of the private space station. So we are very confident that this will come and that we will have our first European contracts actually in the coming month, if everything goes well. And this is how the business equilibrates itself actually for the development costs.
Right. Well, very exciting. I want to go back to something you mentioned earlier on the show, which is commercial traction. So maybe let's go back to that. Tell us a little bit about the contracts that you've signed so far and how those are structured, how that's going.
Yeah. So actually, we've signed kind of 2 types of contracts. The first one is for our second capsule, so still the re-entry demonstrator. It's a 1.6 ton capsule, 2.5 meter diameter. And we have built this capsule for technical purposes at the beginning to de-risk the re-entry. But I was kind of, okay, this is so crazy. Like, we are spending a lot of money on something which could have client on board. Let's try to sell that stuff. So we started selling this capsule. The company was 6 months old, and I was having PowerPoint with like no CAD design, nothing, just a kind of sketch. Coming to, European Space Agency and Airbus, they are saying, do you want to fly with us? We fly in 24. And actually, people said yes. So now this first capsule is sold out. We are super proud of that, because for a company which had literally no product and PowerPoints, and we could generate like a sales traction. Because a lot of people want to fly, actually. And there is a real demand for microgravity experiment at a very low price. There is a real demand for IOV, IOD, in-orbit validation demonstration for very low price. So that's kind of small contract that we've signed, but what's critical for us at the beginning of the company. Now we are discussing, of course, like bigger contract, real mission contract. And this is the core of our business. So the deals we have signed with Axiom Space, for example, we hope to sign with European Space Agency next semester. So before May 24, it's a mission contract. So they buy one mission. Hopefully in the future, they buy batches of mission. And right now, so the one we have signed is with Axiom Space. We're, of course, having similar discussions with other private space stations like Voyager, VAST. And we are having, of course, discussions with European Space Agency, but also other agencies in the world, so that they buy the same kind of mission contract. So on the roadmap, basically, before we start raising Series B, we want to have 2 of these kind of mission contract being signed. And what would be great, we have one in Europe and one in the US. The US, we already have one. I hope to have 2 in the US very soon. 3 will even be like great, 1 in Europe, 2 in the US. But okay, let's see.
So I want to put my investor hat back on and ask a question. And I'll start with the dynamic that exists in launch, right? I think there's a feeling that there's a lot of launch providers out there, and that for investors, sometimes it can be hard to differentiate and understand, especially when you have companies with amazing engineering talent, all having some type of unique capability or technical addition that they're adding to their vehicle to try and differentiate themselves. But ultimately, what I've also seen is that a really interesting way to think about the launch market is think about it globally and not just focused on, for example, if you're in the US, just on US players. And what you actually start to see is that even though there are many launch providers, there is in and of itself a opportunity to invest in domestic launch providers of other countries, because there's an argument to be made that the UK, for example, or France, or Germany, or Australia, doesn't want to. They don't want to rely on a SpaceX, right? They don't want to rely on another country's launch provider, and they have their own kind of homegrown vehicle. So I'm curious if that same type of dynamic do you think will exist for crew or cargo capsules? Meaning, will you have an advantage in the sense that if you will be the first privately funded crew capsule or majority privately funded crew capsule in Europe, and that in and of itself could be substantially exciting, and both for an investor and obviously for you as well, because even if there is Starliner and Crew Dragon, that ultimately that's going to be a significant tailwind for you, or a significant outcome ultimately.
Yeah, so it's clear that I think some country in the world, and more they will be willing to have their own in-space transportation capacity or their own capsule. If you take the launcher as a comparison, I think what matters for countries is the capacity to launch themselves their military satellites, because you don't want to give the technology to another country, and you don't want to know that the other country knows exactly the orbit and where you launch, etc. So that's why at the end of the day there is really this need to have an access to space which is somehow independent. And I believe the same is going to happen, because as we're saying, we have a militarization of what's happening up there. So like in-space transportation is not only for bringing cargo and people to civil space station, but also to be able to perform some in-space operations with exactly the same technology. And I think there will be, for the same reason, the need for having independent in-space transportation capabilities for every country in the world. So then for Europe, as I was saying, we have nothing. Europe needs its own capsule, because there is some European need to bring cargo people into space. And there is also the need for Europe to barter with the US, because today we also don't have capacity to fly to moon and etc. So on the one hand, for our own needs, like civil and military, plus for this barter capacity, Europe will have a need of a capsule that will be at the beginning 2 missions per year, and then could in the future be up to 4 to 5 missions per year. On top of that, of course, we want to expand in other markets. I don't want to stay in Europe. That would be too small, and it's not the purpose of the company. So for the US, which is a very important market, once we have flown our first product in 2027, we want to create a production line, and we want to serve the American market while producing in US. We believe that's the best way to serve the American market. So hopefully we can then also, let's say, serve that market and become, let's say, an American partner with European routes for the American market.
So you're talking a little bit about the future. Just to wrap up here, Helene, I'm curious, what is your vision? What is your long-term vision for the company? Obviously you're starting with a crew capsule and a cargo crew capsule that looks like what we have out there right now. But what does the company look like in 10 to 20 years? What other products are you hoping to see?
Yes, we're thinking about other products. At the end, I would love the Exploration company to be a full transportation company. So not doing only capsule, but also doing launchers. And I think also, let's say, when we look at the design of Starship, I think that's the design of the future, where you have a ship, you have a booster. So this is for the future. Amazon wouldn't have grown if they wouldn't have been successful with the books. So our first product is the cargo capsule with the potential to fly crew afterwards, and we need to be successful with this first product. But of course, we have plans for the future, and all the technology that we develop for the capsule and for landing on the moon, or technology that can be reused afterwards to develop much bigger and much more ambitious stuff. And I don't want to say too much, but of course we have already design ideas of what we would like to bring on the market, and it's something very new. We start with the capsule in a design which is very traditional because it has to fly, it has to be successful. But if we're successful with this first step, the second step will be very untraditional, and hopefully we'll be able to disrupt a little bit our industry. So I would love that.
Well, we're excited to see what it is. But Helene, thank you so much for being on the show.
Thank you very much.
This is great. This is our first crew capsule, or cargo. I keep saying crew capsule, but first capsule company.
It will be crew. Just we
It
start with
will
cargo.
be crew, but cargo and crew capsule company on the show. So very excited. It was a great conversation. Very excited to see where the business goes, and also excited to see what this new variant of I don't know what to call it. I'm not going to say capsule because I don't know what it is, but whatever the next product looks like, we're excited to hear about it and see about it. But thank you for being on the show. It was a pleasure, and enjoy India.
Thank you for having me. Yeah, thank you very much. Thank you, Mo. Goodbye.